Let us look at proposition number 10 of works of Archimedes, specifically from on conoids and spheroids. The proposition says any segments of cones have to one another the ratio compounded of the ratios of their bases and of their heights. So we are given a cone and a segment of a cone is a portion of the cone cut by a plane parallel to the base. So let's cut it with a plane. So this plane intersects this cone, forming a circle of intersection. And in the process, it creates a smaller cone, and the bottom part is called the frustum of the cone. Now the top part is a cone similar to the original cone. Do a little bit of construction. Let's draw the height of this cone, the original cone. This height is the height of the frustum, and this is the height of the smaller cone. Now let's say D is the center of the base of the smaller cone, and let's draw the diameter of the smaller cone's base, EF. And similarly, let's draw a line parallel to EF in the circle P. And let's mark the points B and C and A. Now, let's have another plane which cuts off this cone and again forms a circle of intersection, and in the process forming a cone, a smaller cone than the original. And again, let's join these points. Okay, now for clarity's sake, I'll remove these planes. So now cone OHK is to cone OEF is equal to the base of the cone OHK is to the base of the cone OEF times the height of this cone, that is GO, is to the height of this cone BO. Again, R is to Q, that is circle is to circle, is nothing but the duplicate ratio of the radii. So GK square is to DF square. So we have shown that the segments of the cone have to each other a ratio compounded of the ratios of their bases and of their heights. So here, remember, we are not specifically looking at duplicate ratios. We are just saying that the cones have to one another ratio compounded of the ratios of their bases and of their heights. Now, since the frustums are in the same original cone, that means their bases are proportional to their heights. So AC is to GK is to DF is equal to AG is to GD is to DO. So which means we can say frustum HPCK is to frustum EHKF is equal to AC square plus GK square plus AC times GK is to GK square plus DF square plus GK times DF times AG is to GD. So this is the ratio of the bases. This is the ratio of the heights. So frustum is to frustum is equal to the compounded ratios of the bases and their heights. Similarly, we can show for smaller cone OHK is to frustum HBCK is equal to GK square is to AC square plus GK square plus AC times GK times OG is to AG. That was the first part. There is another part of the proposition which we'll look at it now. The second part of the proposition says that any frustum of a cylinder is triple of the conical segment which has the same base as the frustum and equal height. So what does this mean? So we have a cylinder. Let's mark the center of the base of the cylinder, and here we have to cut this cylinder using two planes. So plane 1 and plane 2. Now they will form a circle of intersection, and in the process it will form a cylinder, and this cylinder is called the frustum of the cylinder. So this frustum of the cylinder is triple of the conical segment, that is, which has the same base as the frustum and the same height as the frustum. So let's again mark some points. So now, frustum of a cylinder is a portion of a cylinder cut by two parallel planes perpendicular to the axis of the cylinder. Or we could have said parallel to the base of the cylinder. And this frustum is also a cylinder. And this is a cone with the same base as this cylinder, the frustum, and the same height, which means volume of the frustum of a cylinder is equal to 3 times the cone with the circle on Lm as base and height equal to Kj, that is height of the frustum. Pretty straightforward. Yes. So that was proposition number 10 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.